This is question 3 and 4, module 6, page 169. And this time we're using our halogen reactivity table to see if a nonmetal will replace a nonmetal. Over here, fluorine's the most reactive, iodine is the least reactive, so everything under fluorine will be able to replace all the elements underneath it. Iodine won't be able to replace anything. Now the states are a little bit tricky, so you'll notice here bromine on the reactant side is a liquid, chlorine's a gas, fluorine's a gas. Iodine's actually solid at room temperature, and we are dealing with those that are at room temperature, those states. But for single replacement, all of our products are going to be aqueous for the nonmetals, and so that's a little bit easier. I did find this PowerPoint just as some tips. So gases at room temperature: hydrogen, nitrogen, oxygen, fluorine, chlorine. I probably won't get into these in the course. Ammonium, carbon monoxide. We probably know some of these anyway as gases. Acids are always aqueous. That comes in module 11, I believe. And we've covered aqueous as ions in solution already for double displacement. Liquids: bromine, mercury, and water. Water is always going to be liquid in this course. Same with bromine. And then all elements are solid. So that's something you can consider when you're deciding on your reactants. But in single replacement and double displacement or single displacement, we are going to decide as our products, they're going to be aqueous for single displacement, and then in double displacement, we can use our solubility table to determine that. So now the first question, bromine to iodine. Bromine is higher than iodine, so of course it is going to replace it. And I'm going to get sodium bromide plus iodine. And as I mentioned, we are going to put AQ for our products. And if you're unsure how I got to this, sodium's in group 1, bromine is in group 17, so it's got a 1 negative charge, crisscross, and you get NaBr. And then from there, we just, of course, have to balance. So it's pretty straightforward. 2 in front of this, 2 in front of that, and we have a balanced chemical equation. Chlorine cannot replace fluorine because fluorine is the most reactive. So all we have to do is write no reaction for this one. And then finally for the last one, as I just mentioned, fluorine's the most reactive, so it is going to replace bromine. And you would just then write calcium fluoride plus bromine as a diatomic. They're both going to be aqueous. And if you're unsure how I got to CaF2, calcium's in group 2. Fluorine is in group 17, so it has a 1 negative charge, can only accept 1 electron. So you use your crisscross rule because it's ionic to get calcium fluoride. And then, of course, we do have to balance, but it looks like everything is 1 to 1, so it is already balanced. For question 4, it asks you to now use the activity series to rank these reactions in order from slowest to fastest. And as you'll notice, each of these are the same compound, silver nitrate. So we're reacting zinc, magnesium, potassium, and gold. And we're trying to see what is the most reactive. So it's quite easy to figure out that gold is the least reactive because, in fact, we aren't even going to have a reaction happening. So I can just write no reaction here. And then I just have to look at zinc, magnesium, and potassium and look at the greatest difference. So here is potassium, so that is going to be the most reactive. It's at the highest end of those 3, and then magnesium, and then zinc. So the distance between those and silver, potassium is going to have the greatest distance. So we can say that it is going to be more reactive. So it's pretty straightforward to then rank them accordingly. It says from slowest to fastest. So this is going to be the slowest, gold. Gold is going to be the slowest, then zinc, then magnesium, and then potassium is going to be the fastest.